Okay, thank you. Good day, students. Welcome to the introductory lesson on MAE102K. This lesson is focused on providing you with a general overview of the concepts that you will engage with during this semester. My name is P.D Motseki. I am the module lecturer and the presenter. The module MAE102K is aimed at equipping you with appropriate knowledge and skills in the teaching and learning of geometry, trigonometry, and spatial sense in intermediate and senior phase mathematics. The purpose of the module is to develop your spatial sense and to expand your teaching practice by suggesting few fresh and exciting principles for enhancing your learners' spatial sense and experience. There are four main outcomes for this module. The first one is for you to be able to name and describe each of the 5 Van Hille levels of geometric development, to be able to name and explain different isometric transformations such as the reflections, translations, rotations, and glide reflections, for you to be familiar with geometric shapes as well as their properties, and to be able to define and apply trigonometry in right-angled triangles. All these four learning outcomes, we find them under the umbrella name, which is called the spatial sense. And then the spatial sense is the intuitive awareness of one's surroundings and the objects in them. Geometry helps us to represent and to describe objects and their interrelationships in space. A strong sense of spatial relationships and competence in using the concepts and language of geometry also support the students' understanding of number sense and measurement. Spatial sense is necessary for understanding and appreciating the many geometric aspects in our environment. Insights and intuitions about the characteristics of two-dimensional shapes and three-dimensional figures, the interrelationships of shapes, and the effects of changes to shapes are important aspects of spatial sense. Students develop their spatial sense by visualizing, by drawing, and by comparing shapes and figures in various positions. In this strand of mathematics, students learn to recognize the basic shapes and figures, to distinguish between the attributes of an object that are of geometric properties and those that are not, and also to investigate the shared properties of classes of shapes and figures. Mathematical concepts and skills related to location and movement are also addressed in this module. One of the strands that we will be focusing on is Van Hille levels. And the best known part of the Van Hille model are the 5 levels, of which the Van Hille postulated to describe how children learn to reason in geometry. Students cannot be expected to prove geometric theorems until they have built up an extensive understanding of the systems of relationships between geometric concepts. These systems cannot be learned by rote, but must be developed through familiarity by experiencing several examples and counterexamples in various properties of geometric figures, the relationships between the properties, and how these properties are ordered. The 5 levels postulated by the Van Hille describes how students advance through this understanding. And then in looking at the Van Hille levels, the first level is known as, the first level of Van Hille is known as level 0 of visualization. At this level, the focus of a child's thinking is on individual shapes, which the child is learning to classify by judging their holistic appearance. For instance, children might say, this is a circle, this is a square, or this is a triangle, usually without further description. This means that children identify prototypes of basic geometrical figures. These visual prototypes are then used to identify other shapes. A shape is a circle because it looks like a sun. These are some of the reasons that might be provided at this level. A shape is a rectangle because it looks like a door or it looks like a box, and so on. A square seems to be different sort of shape than a rectangle, and a rhombus does not look like other parallelograms. So these shapes are classified completely separately in the child's mind. And then children view figures holistically without analyzing their properties. If a shape does not sufficiently represent its prototype, and then the child might reject the classification. Thus, children at this stage might balk at calling a thin wedge-shaped a triangle with sides 1:20:20 a triangle because it is so different in shape from an equilateral triangle, which is the usual prototype of a triangle. And then the properties at level 1, which is called an analysis level. A learner at this level might say, a square has 4 equal sides and 4 equal angles. Its diagonals are congruent and perpendicular, and they bisect each other. The properties are more important than the appearance of the shapes. If a figure is sketched on the blackboard and the teacher claims it is intended to have congruent sides and angles, the student accepts that this is a square, even if this shape is poorly drawn. Properties are not yet ordered in this level, which is the analysis level. Learners can discuss the properties of the basic shapes and recognize them by their properties, but generally they do not allow the categories to overlap because they understand each property in isolation from the others. For instance, they will still insist that a square is not a rectangle. They may introduce or they may support this by introducing extra properties to support their beliefs, such as defining a rectangle as a shape with one pair of sides longer than the other pairs of sides. Learners begin to notice many properties of shapes, but they do not see the relationship between the properties. Therefore, they cannot reduce the list of properties to a concise definition with necessary and sufficient conditions. They usually reason inductively from several examples, but cannot yet reason deductively because they do not understand how these properties of shapes are related. And then the next level is level 2, which is also known as abstraction level. In this level, the properties of shapes of 2 dimension or 3 dimension are ordered. The objects of thought are geometric properties, which the student has learned to connect deductively. Learners understand that properties are related and one set of properties may imply another property. Students can reason with simple arguments about geometric figures. For instance, a learner at this level might say, isosceles triangles are symmetric, so their base angles must be equal. Learners recognize the relationship between types of shapes. They recognize that all squares are rectangles, but not all rectangles are squares. And they understand why squares are a type of rectangles that are based on an understanding of the properties of each. They can tell whether it is possible or not to have a rectangle that is, for an example, a rhombus. They understand necessary and sufficient conditions necessary and can write concise definition. However, in this level, they do not yet understand the intrinsic meaning of deduction. They can follow complex arguments, understand the value of definition, or grasp the need for axioms, so they cannot yet understand the role. Sorry, can I go back a little? They cannot yet understand the role played by defining the theorems. And then for intermediate and senior phase learning, we will focus on the first three levels as level 3, which is rigor, which is deduction, and level 4, which is rigor, are relevant for high school or college mathematics students. And then another point that we need to focus on, that we will be focusing on in this module, is what we call the transformation geometry. In transformation geometry, we have several important points that we will also be focusing on. The first one is what we call translation. A translation is a movement along a straight line on a fixed direction without any turning, as indicated by a diagram or by an example on the screen. When an object undergoes a translation, all points on the object move the same distance at the same direction. So in this case, we are guided by the arrows between the object and the image in order to understand what translation is about. And then we have what we call the reflection. In a reflection, a perpendicular distance between an object point and an image point from the mirror line is the same. This property enables us to locate the image in a reflection, as indicated or as shown by an example on the screen. And then we have another term, which is rotation. A rotation is defined as a geometric transformation in which an object is turned or is rotated about a fixed point. And then on our screen, we have an example of a rotation of 180 degrees about the center of origin or the center O. And then the last part on the module, on the most important basic concept on this module, is trigonometry. And then trigonometry is a branch of mathematics that deals with relationships between the side lengths and the angles of triangles. For this module, our center of attention will be on the trigonometric ratios. So looking at an example on our screen, is an example of a right-angled triangle with the adjacent side. So the adjacent side is the side next to the angle theta, which is indicated in blue. And then we have the opposite. The opposite is the side that is opposite the angle theta, is represented in yellow. And then we have the hypotenuse, which is regarded as the longest side in a right-angled triangle. And then we have what we call the trigonometric ratios. These are the ratios between the edges of a right-angled triangle. These ratios are given by the following trigonometric functions of the known angles. So in our triangle, we have angle A, where small a, b, c refers to the length of the side in the accompanying figure. And then the trigonometric ratios that we will be focusing on in our module is the sine, the cos, and the tangent. And then looking at our triangle, we have sine A, which is the opposite over hypotenuse. In our right-angled triangle is referred to as A divided by C. And then we have the cos of A, which is represented as the adjacent divided by the hypotenuse. And then in our given right-angled triangle, this is represented by B divided by C. And then the tangent of A is the opposite divided by the adjacent. In the accompanying diagram, this will be represented as A divided by B. And then looking at the assignments for this semester, we will be having two main assignments. The first assignment is the multiple choice assignment, which contributes 20% towards the semester mark. And then this assignment is also important in a sense that it allows you to gain an entrance into the examination. So for you to be able to sit for your exam, you will need to complete and submit your multiple choice assignment, which is the assignment 1, relative to the semester in which you are registered for this module. And then the next assignment is assignment 2, which contributes 80% towards the semester mark. The assignment total is normally at 150 marks, but to facilitate the quick and effective marking, the lecturer will select a sample of questions which normally total to 100 marks to facilitate a quick and effective assessment procedures. And then the marking guideline with all the questions and answers will be provided upon the releasing of the assignment 2 marks. And then the contact details of the lecturer. You can find me at Simon Ngwanaradi Building, floor 7, office 42. Alternatively, you can email me at motsipd@unisa.ac.za, or alternatively, you can contact me at 012-429-4177. When intending to visit the campus, please make proper arrangements in adhering to COVID-19 protocols. I wish you a good and fulfilling academic year when studying this module. Thank you.